Welcome back. This is part 2 of this lesson. We're going to continue immediately from the end of part 1, so let's get started. The principle of dynamic NAT is similar to static, except devices are not allocated a permanent public IP. Instead, they're allocated one temporarily from a pool. Let's say that we have two public IP addresses available for use, 52.95.36.66 and 67. But we have 4 devices on the left, and all of them at some time need to use public addressing. So we can't use static NAT because we don't have enough public IP addresses. With dynamic NAT, the public to private mapping is allocation based, so it's allocated as required. Let's look at an example. Let's assume that the server on the top left is trying to access the CAT API. Well, it creates a packet, the source IP address is itself, and the destination IP is the CAT API, which is 1.3.3.7. So it sends this packet, and again the router in the middle is the default gateway for anything which is not local. As the packet passes through the router or the NAT device, it checks if the private IP has a current allocation of public addressing from the pool, and if it doesn't and one is available, it allocates one dynamically and on a temporary basis. In this case, 52.95.36.67 is allocated on a temporary basis. So the packet's source IP address is translated to this address, and the packets are sent onto their final destination. The CAT API is able to send response traffic back using this public IP allocation. So this process is the same so far as if we were using static NAT, but because dynamic NAT allocates addressing on a dynamic and temporary basis, multiple private devices can share a single public IP as long as there is no overlap, so as long as the devices use the allocations at different times. In this case, the upper laptop is accessing the CatFlix public service using 52.95.36.66, and then afterwards the lower laptop is using the same public IP address to access the Dogflix application. With dynamic NAT, because this shared public pool of IP addresses is used, it is possible to run out of public IP addresses to allocate. If the bottom server attempts to access the public internet when there are no IPs available in the pool to allocate, then this access will fail. Now, this type of NAT is used when you have less public IPs than private ones, but when all of those private devices at some time need public access, which is bidirectional. Now, the last type of NAT which I want to talk about is the one which you're probably familiar with. This is port address translation. This is the type of NAT you likely use on your home network. Port address translation is what allows a large number of private devices to share one public address. It's how the AWS NAT gateway functions within the AWS environment. It has a many-to-one mapping architecture, so many private IP version 4 addresses are mapped onto one single public IP version 4 address. Let's step through an example because this will make it easier to understand. The example we'll be using is 3 private devices on the left, all wanting to access CatFlix on the right, which has a public IP of 1.3.3.7 and is accessed using TCP port 443, which in this case is HTTPS. And to make things easier, I'll be color coding the laptops, so red for the top, purple for the middle, and yellow at the bottom. Now, the way that port address translation, or PART, works is to use both IP addresses and ports to allow for multiple devices to share the same public IP. Every TCP connection, in addition to a source and destination IP address, has a source and destination port. The destination port for outgoing connections is important because that's what the service runs on. In this case, CatFlix uses the destination port of 443. The source port, this is randomly assigned by the client, so as long as the source port is always unique, then many private clients can use the same public IP. Let's assume that the public IP address of this NAT device is 52.95.36.67. So at this point, let's say that the top laptop, so the red laptop, generates a packet, and the packet is going to Catflix. So its destination IP address is 1.3.3.7, and its destination port is 443. Now the source IP of this packet is itself, so the laptop's private IP address, and the source port is 32768, which is a randomly assigned ephemeral port. So this packet is routed through the NAT device on its way to the internet, and in transit, the NAT device records the source IP and the original source private port, and it allocates a new public source port, which in this case is 1337. It records this information inside a NAT table, and it adjusts the packet or translates the packet so that its source IP address is this single public address which the NAT device uses, and the source port is this newly allocated source port which is now recorded within the NAT device, and this newly adjusted packet is forwarded on to Catflix. If the middle purple laptop did the same thing, then the same process would be followed. It would record all of this information, it would allocate a new public source port, and would translate the packet, so adjust the packet's source IP address and the source port to these newly defined values. Now if the bottom laptop, so the yellow laptop, generated a packet, note how this time the source port which is randomly assigned is the same source port that the top or red laptop is using for the same connection. But the same process would be followed. The NAT device would pick a unique source port to allocate, and it would translate this packet. It would change the source IP address from the private IP to the single public IP, and it would change the source port of 32768 to a unique new source port, in this case 1339. Now normally the reason that only one device can use the same public IP is because these source ports are randomly assigned. If multiple devices communicate with the same destination service using the same destination port and they happen to use the same source port, then it will look like the same connection. What the NAT device is doing is creating this, a NAT table. The table is updated with the original private IP and private source port and the new source IP, which is the public IP address of the NAT device, and then the newly allocated public source port. This means that when response data comes back, this table can be referenced to ensure that the packet reaches its destination. So when return traffic occurs, it will be from TCP port 443 with a source IP address of 1.3.3.7. The destination IP will be the NAT device's public IP, so 52.95.36.67, and the destination port will be the public source port the NAT device initially translated to. Let's say in this case the public source port is 1337, which represents the session of the top left laptop. So for return traffic, if an entry is present in the NAT table, the NAT device translates the public IP and public port, which are the destination IP and port, to the original IP, which is 10.0.0.42, so the top laptop, and 32768, which is the original source port number. Now it's worth pausing and making sure that you really understand how this process works, because it's how your home router works and it's how the NAT gateway within AWS works. Once you understand it, you'll understand why with port address translation you can't initiate traffic to these private devices, because without an entry in the NAT table, the NAT device won't know to which device traffic should be translated and forwarded to. Now I hope all of this has made sense and you understand all of the different types of NAT. NAT is a great topic to understand because it's one of those things which is used constantly within most architectures, cloud platforms, and even home and business networks. Now that's everything I wanted to cover though, so go ahead and complete this video, and when you're ready, I look forward to you joining me in the next video.